Okay, now we're going to take a look at some triangular prisms and finding surface areas for those. A little bit more complicated, some things you've got to think about when you're working on those. First of all, is what kind of triangular prism I've got. When I'm taking a look at this prism and I'm looking at the triangles that form it, I'm looking and I know at this point I've got an isosceles triangle. These two sides are the same. This one is not. So when I look at which ones are going to have sides that are the same, because this side and this side are congruent, I know that this rectangle and this rectangle are going to be congruent, but this bottom one is not. So I've got to keep an eye on that. And looking at the prism that formed it, you can see it a little bit easier. Again, because I've got an isosceles triangle with two sides that are the same, I know that I'm going to have two rectangles that are going to be congruent, another rectangle that's going to be different. And on this one, I've got to be really careful when I'm figuring out the area for the triangle, because remember when we talked about this, we talked about dangling that string. This is not the height of this triangle. The height of this triangle runs straight down the center. So you've got to imagine dropping a line here. That's where you're going to find the height for that triangle. So we're looking for a number there if we've got an isosceles. There are other kinds of triangular prisms that you might run into. You might have one like this one, where the triangle that forms it's actually scalene. So all three sides are different. So all three of my rectangles are going to be different as well. Even though I colored these badly, should have made each one a different color because all of these sides are going to be different. When I take a look at the net for this I can use as the height of my triangle when I go to figure it out, because I've got a nice perpendicular here. So if I were to walk up the top of this hill and drop a line off, it's going to go here. That's really the height of that triangle. And when I look at all the sides for these, I really should have these two colored differently because they're not the same. This side would line up here, so that's a 5. This side would line up here, so this is a 4. I know these are both 7s. So this would be a 5 by 7 rectangle. That would be a 4 by 7 rectangle. And then this one would give me the 3 by 7 rectangle. So when you're looking at the 3D shapes, you got to kind of try and pull them apart in your head. And I really do look at the sizes of those triangles to figure it out. So if I wanted to go ahead and figure out one of these and find the surface area of all the sides, let's take a look at this one. This one, again, I know I've got one that's scalene. In fact, it's real similar to the one that I just showed you, except for it's a little bit taller. So when I look at my triangles, this triangle and this triangle, they're going to be the same. So if I'm thinking about surface area for a triangle, I know the area for just this part, this triangle, is going to be 1/2 base times height. That's going to give me my triangle. The height of this triangle is 3. The base would be 4. But I really want to do this triangle and this triangle together. So I'm going to get them both. So when I'm thinking about my formula, I'm not going to do the 1/2 part because I'm just going to multiply by 2 again, right? Does that make sense? If I did the 1/2 base times height, I'd get 12. Divide by 2 and get 6. But then there's 2 of them, so I'd have to multiply again. So I'm just thinking that I've got a 4 by 3 cut in half, but another 4 by 3. So together, that's going to give me 12 centimeters squared. So that gets this triangle and this triangle. Now I've got 3 rectangles I've got to figure out. I've got this small rectangle here, and I label everything when I'm doing this so I can keep track of where I'm at. That small rectangle is a 3. And now I got to figure out how long this is. So I'm going to look over here. This side and this side have got to be the same. So that's got to be a 3 by 11 to get here. And that's where these get tricky because you really have to figure out where to pull your numbers. I know this side is a 3. This is 11, so I'm going to slide it up here. That's also an 11. So that one, the small one on the left side, is going to be a 3 by 11. So that one's going to be 33 centimeters squared. Then I've got to figure out this bottom rectangle here. So I'm looking at the sides for that, and I'm going to label everything. So that bottom rectangle, I'm going to have a 4, and I'm going to have an 11 for my two sides. So I'm going to have 44 centimeters squared for that. Then I've got one more rectangle, and that's this flat one that's up on the top. It's the top piece kind of covering up the rest of the rectangle, or the rest of the triangle. So if I'm trying to figure out that one, that's got a side of 5 and a side of 11. And sometimes it's even helpful if you're trying to figure these out to shade them so you can see them and make it kind of pop in. There's that one up on the top, that's the 5 by 11. So that one's going to give me my 55 centimeters squared. Wow, it's a lot of work to figure these out. So the two triangles, the small rectangle, the bottom rectangle, the top rectangle, I've got to find the total of those in order to get the full total. So there's 144. So surface area of this entire triangular prism, 144 centimeters squared. Wow.